Hi there and welcome to today's class. For today's chemistry class, we'll be looking into the concept of nuclide symbol. Alright, let's discuss the concept behind nuclide symbol and let's look at how to solve some example on the concept of nuclide symbol. Alright, by definition, a nuclide symbol is simply a symbol that shows the atomic number and the mass number of a given element. So that's like definition for nuclide symbol. So one line space paragraph. Given a nuclide symbol X, given an element X, an atomic number Z and mass number A. I'm saying that given an element X and an atomic number Z and mass number A, its nuclide symbol is written as an element X, atomic number Z and mass number A. So this is like the concept behind nuclide symbol. So if I give an element X, an atomic number Z and mass number A, the symbol or how you write it in terms of nuclide symbol is this. So this becomes element X, atomic number and the mass number. So it means that if I give an element, let's say calcium or chlorine, let's say calcium is here now. Any number I'm seeing here is simply the atomic number. Any number I'm seeing is what is the mass number. So before we dive into complex problem, let's record the following, please. Let's record something, or perhaps note the following. Number one, note the following. Number one, note the following. Number one, note the following. The atomic number of an element is equal to the number of protons in an atom of that element. Note number one, I said that the atomic number of an element is equal to the number of protons in an atom of that element. That's number one. Note number two, the atomic mass of an element is equal to the sum of proton and neutron in an atom of an element. Note number two, the atomic mass of an element is equal to the sum of neutron and proton in an atom of an element, or if you want to, proton before neutron or neutron before proton. This one that is simply the sum of proton and neutron in an atom of an element. That's number two, very important concept you need to note. All right, these are the two main important logic or perhaps idea you need to note when it comes to the concept of nuclide symbol. So I'm saying that number one, I'm saying that the atomic number, that is atomic number, is equal to what? Number of proton, right? So let's say I have what we all know the idea of atomic number now. What's the atomic number of hydrogen? That's 1. Carbon, hydrogen, helium, lithium, beryllium, boron, that's 6. So you just count them. So the position when it comes to counting, the position where every element falls in terms of number is called the atomic number, right? So we all know atomic number. So if I'm given atomic number to be equal to 6, it means that the proton is what? Is 6. That's the first thing I said you should note. The second thing I said you should note is that the atomic mass, or perhaps the atomic mass, or if you want to the mass number, if you want to call it mass number, we said is equal to what? The addition of what? Neutron plus what? Plus proton. So to get atomic mass, simply add up what? Neutron plus what? Electron plus proton, please. So now the concept behind nuclide symbol now is that we'll be trying to get the number of proton, electron, and neutron in an atom of an element. So last class when we discussed about number of particle in an element or a ion, we just look for proton and electron. How to look for proton and electron in that last class. But for today's class now, we're talking about how to look for proton, neutron, and electron. So let's take some example to further explain the concept behind this man here. Example one. All right, let's say I have an isotope of hydrogen. One here. Plus sign here. So I'm trying to find the total number of proton, electron, and neutron in this isotope of hydrogen. So how do you find the number of proton, neutron, and electron? Note that this X here stands for element. So I have an element of what? Hydrogen here. This Z here stands for what? Atomic number. So this becomes my atomic number, which is correct. While it's called mass number, known as A, as mass number, which is the weight, right, of the element. All right, let's get the number of proton, number of neutron, and number of electron in this nuclide symbol here. So we said, first things first, we said that for the let's get proton, we said the atomic number is equal to number of proton. What's the atomic number here? Atomic number is this one here, right? As we said earlier, that Z, atomic number Z. So atomic number here is 1. So it means that proton is also what? Is 1. So atomic number is equal to what? Number of proton. So if atomic number is 1, it means proton is what? Proton 2 is 1. We are done. Let's get neutron. We said to get neutron, the idea is quite simple. We established that atomic mass is equal to what? The sum of what? Neutron plus proton. So it means that atomic mass now, to get neutron, what is my atomic mass? Atomic mass is this one here, 3. That is 3, which is equal to, atomic mass is equal to what? Neutron that I'm looking for, plus what? Plus proton, P. So it means that 3 is equal to, what's neutron? We don't know yet. Plus what's proton? We just said proton is what? Is 1. So I have 1 here. Apply mathematics concept. Take this one here. I'll have 3 minus 1 is equal to neutron. Therefore, neutron N is equal to what? 2. So my neutron here is 2. That's how to calculate for neutron. Let's get electron. We said when it comes to getting electron in our last class, we said to get electron, here's what you need to ask yourself. Is this one here, is it a neutral atom? Of course, this one what is not a neutral atom. Why? It's having a charge, a positively charge. So when is an element said to be neutral, or an atom said to be neutral? An atom or element is said to be neutral when it has no charge. This one has a charge, a positive charge. So it is what? Is not a neutral atom. But let's assume that this plus sign is not there. Becomes what? A neutral atom. And we said the idea is that for a neutral atom, there are equal amount of proton and what? Electron. So let's say if this one is neutral, if proton is 1, it means what? Electron is what? Electron is what? Electron is 1. If it was neutral, proton is 1. Hence, electron is 1. But I'm having a positive charge here. What's the expression for positive charge? It means what? Hydrogen is what? Losing 1 electron. That becomes minus 1. Hence, my electron becomes 0. So it means for this one here, the total number of proton is 1, total number of neutron is 2, total number of electron is what? Is 0. So this is how to calculate for total number of proton, neutron, and electron in an atom of an element. Let's take example 2. Example 2. Let's say I have calcium with a positive charge, a 2 positive charge plus 2, and atomic number 20, mass number 40. So let's get the proton. Let's get the number of proton, neutron, and electron here. Before we start solving this one here, let me emphasize on something. What's that thing? We know that this is what? is simply what? The mass of the element, mass number, or the atomic mass if you want to. It's simply the weight of the element given, right? So the idea is that, let's say we're just given something like this in exam. We're not given the mass number. How do you know the mass number is 40? How do you know? The idea is quite simple. Let me let you note something. This is a kind of guessing, right? A kind of guessing. Note that we know that to get the atomic number is simple. Just count hydrogen, helium, lithium, beryllium, boron, carbon. Carbon is 6. That atomic number is simple. But to get the mass number, here's a concept. I'm not saying that's a perfect calculation, but it's just a guess, right? It gives you an accurate guess. So to get the atomic mass of an element, note that the atomic mass of an element is twice the atomic number, or twice the atomic number plus 1, or twice atomic number minus 1. For this case here now, why is it 40? Because my atomic number is 20. So this becomes a condition on what? Twice atomic number. So this one now, 20 times 2 will give 40 as the mass number. So for this one now, the condition here is what? Twice atomic number. We said we have twice atomic number, or twice atomic number plus 1, or twice atomic number minus 1. What we know, we have chlorine. Atomic number of chlorine is what? Is 17. Let's get mass number. Before now, mass number is 35. What we know generally is 35. Let's now get 35 here. How? We said the condition is what? Twice atomic number. 17 times 2 will give 34. But this is not 34 here. We said if that one doesn't work, do what? Twice atomic number plus 1, add plus 1 here, that will give 35. So to get the mass number of chlorine, it simply was twice atomic number plus 1. There are some other cases which is twice atomic number minus 1. But this is the concept behind guessing on how to get the mass number of an element. Let's get proton. Proton here is what? Is 20. Why? Atomic number is 20. Proton is 20. Let's get neutron. To get neutron, we said it's quite simple, that the mass number, which is 40, is equal to what? Neutron plus proton, which is 20. Yeah. Let's get neutron. 40 minus 20 is equal to neutron. Therefore, neutron is equal to 20. So my neutron here is 20. Let's get electron. To get electron, what's the idea? Ask yourself, is this a neutral atom? No. Why? It's 20. If it was what? A neutral atom. But this one here now is having a 2 plus. 2 plus means what? Losing 2 electrons. So I have what there? Minus 2. That becomes 18. So total electron is 18. Neutron is 20. Proton is 20 for this nuclide symbol here. So you try to do this one. Give a number of what's it called? Number of proton, electron, and neutron in this nuclide symbol here, and put your answer in the comment section below. I'll reply you as fast as I can. We'll look at how to calculate for relative molecular mass of a compound in our next class. See you in our next class. Thanks for watching. Do well to join us in our WhatsApp group, which I'll drop a link in the description of this video. So join our WhatsApp group using the link you see in the description of this video. So see you in our next class once again. Bye.